And next we have Irene Wu, Head of Strategy at Layer Zero. Let's welcome Irene to the stage.
Hi guys, can you hear me? Perfect. My name's Irene. I am head of strategy at Layer Zero Labs. And today I'm going to be talking about, in the first ever talk on this, Layer Zero V2, which went live on mainnet about a month ago. And we'll be going through the design principles and how we achieved modular security through this. Okay, so for starters, a little bit of history here. Our founders, they all actually met in university about 15 years ago and were doing research in a Web2 interoperability center and have built projects together over many years. One of them was a professional poker player, 2 others did AI research, and finally came back together around 2020 because they wanted to create a game. This was around the time BNB Chain had just launched, and what was fascinating was that there was actually usage. There were developers and users. It was the first time there was a chain outside of the immediate Ethereum ecosystem that had this kind of cachet and real adoption. So as lifelong gamers, they wanted to create something that allowed for gameplay on both of these chains. You look at all of the bridges that existed at this time, or anything that was empowering interoperability, and it was very, very primitive. These were wrapped asset bridges, which many of you may be familiar with. How wrapped asset bridge works is you have a smart contract, which is owned by some third party, and as a user, you deposit your funds into the smart contract. It's locked in there, and a synthetic asset is minted for you. It's a synthetic IOU. Essentially, should you cross this bridge back and we don't get hacked, you trust us, fingers crossed it's all good, you'll get your real stablecoins. But in the meantime, it has some representative meaning in this ecosystem. As developers, they would never have trusted this. And many of these early bridges were also run by very tiny multi-sigs of maybe sometimes the same people. And we've seen that, I'll get to it later, with hacks like the multi-chain hack, which then really ravaged, unfortunately, ecosystems like Phantom and other ones which were dependent on these wrapped assets. So they set out to create their own bridge. And as they were doing that, which was V0 of Stargate, which is a bridge that our team created, they realized what was a lot more interesting was the layer below bridges. Bridging is just one use case out of thousands for arbitrary message passing or sending data between smart contracts and disparate systems. Below that, you can do arbitrary contract invocation. You can do a lot more than just moving assets. And that was what led to, well, here is the hacks portion. I think I actually have updated slides rather than the PDF. I just want to make sure we're using the updated slides. Gil. One second. But anyways, you guys can take a look at this here. All 3 of these hacks were due to upgradable smart contracts. The multi-chain hack was also one in which the multi-sig was compromised, and the first hack and the last hack there mentioned were wrapped asset bridges. And understanding what the actual reasons are for hacks in cross-chain is incredibly important. Rarely are they because of a validator set and an issue with the decentralization there. It's most often because of the design principles which found the actual architecture of the bridges. Let me see if they're going to update the slides. 1 second. Okay, no worries. While we're waiting here too, a little bit of background. Part of what got me interested in interoperability is that I spent several years doing research in anti-surveillance technology. I studied computer science, and a lot of my interest was within the United States, how our governments, police forces, all of this, use technologies to surveil and potentially enforce particular ideologies or particular disenfranchisement. And at the time, I was looking specifically at machine learning being layered over things like body cameras. But it led me to get more interested in the ideals of censorship resistance. And it's something that stablecoin issuers, many DeFi protocols talk about a lot, but we rarely talk about in the cross-chain context. So what would censorship resistance look like in a cross-chain context? It would look like not being able to reorder messages. So as a message passes across, it's first submitted on the source chain and then delivered in a particular order. if you're trusting a service for this, a team that has built a messaging service but can reorder these messages, it means they can extract more MEV, for example. If they're attached to a high-frequency trading firm, there's more value there that they can extract from your users. If you are a government, let's say 10 years from now, and you're conducting votes on chain, you have everyone voting from different L2s, you want to be able to ensure that it's not possible to withhold a whole slate of votes. If it is, the entire integrity, the entire thesis of what we're all doing here around blockchain technology being adopted at large is breakable, it's corruptible. And that's a tenet that matters quite a lot to me. And in V2, we really enshrine into the protocol. Thank you, Gil, for making this work. There's a slides link that you should be able to use. I can also, while we're waiting, talk a little bit more about V1. There would have been a slide on this in a moment. V1 launched just about 24 months ago. And the hypothesis we had for this, as we were creating what was meant to be a response to this design question of how might you build both an evergreen and evolvable interoperability infrastructure protocol with research and time. Given that we're at this event and it's hosted by Stanford Crypto, I'm assuming that many people here come from an academic research background or have a lot of reverence for what comes out of academic research. The belief is what people use today, Gil, you actually might want to just pull up the slide link.
Yes, so we don't have access.
Oh, okay. Okay. Give me one moment here. Thank you guys for bearing with us. It's all good. Which email is it supposed to be shared to? Okay. Dom, if Lexi's there, can you have her share it? Okay, awesome. Yeah, what I was saying about academic research is if you look at, 2 years ago, ZK proofs weren't performant yet. But now, today, there are teams like Succinct, there are teams like Polyhedra, RISC-0, who have proven that it's possible to build tooling so that it's much easier, for example, to build a custom ZK-like client. And so when you're creating an infrastructure protocol that you're intending for people to use to secure, say, $1 billion worth of value or $2 billion worth of value, it's incredibly important that it's designed so it can evolve with better practices. And that means if, for example, there's now a ZK Oracle that you could leverage, how can you do that in a way that enables modular security, meaning I can select that, I can even propose a DAO vote and it can trigger it and add this change, and at the same time, the immutable components, where there could be a vulnerability in a smart contract, are preserved. The integrity of that is still there. That's a really important piece, and it's what informed how we designed V1, but even more importantly, how we designed V2. Hold on, I think I might be able to help with this. Okay, you should have access now. If you go to your drive and you search for it. If you go to the top right slideshow, or view slideshow, yeah. Okay, amazing. Thank you guys so much. And for everyone in the room, thank you for bearing with us. As I talked about, that was the scene for 2020. The bridges that existed were highly insecure. We set out to build our own bridge. As we did so, we realized what was much more interesting was the layer below it, in which you can enable arbitrary contract invocation and a lot more. But the design question then is, how might we design an infrastructure protocol that is both evergreen and evolvable with research and time? And this is very much rooted in just belief in science and research. And why I emphasize protocol is because there are services. Services are products which require the liveness of the creator company to maintain the integrity of the product. That's, for example, like AWS. There are outages with AWS, and that causes real issues with DeFi protocols, causes issues with relayers, causes issues with many other key components that right now limit the mainstream adoption of what we're creating in this space. It also requires that that team has venture funding, that they're alive. If something happens, a horrible accident, or they run out of funding, your Slack connect with them is gone. That's not DeFi, that's not crypto, that's using some service. A protocol is something that is immutable. You can use it forever, in perpetuity, without trusting that I'm alive, without trusting that I'm still raising venture funding. It's something like TCP/IP or the underlying protocols that have allowed the internet to scale and allowed people to build whatever they would like with it. And so these are the three design principles that came out of that design question. First of all, immutability. Why is this so important for infrastructure? If you can change the underlying infrastructure, that means these subsequent two tenets are breakable, they're peachable, and that's incredibly important to look at when you're choosing your stack for infrastructure. Immutability means that when you choose to integrate Layer 0 for interoperability, there's nothing Layer 0 Labs can do to upgrade it and introduce new vulnerabilities. Even if there is good intention here, and I'll talk about some notable hacks that have been caused in this way. Then permissionlessness. You should be able to use the protocol without having to engage with the developers in some BD contract. You should be able to run your off-chain components or choose the validation methodology on your own time, rather than delegating trust into, say, Layer 0 Labs to tell you what that should look like. And you should also be able to run one of these components yourself, and it should be easy to do that as well. Censorship resistance I spoke about. For messaging, that means if we have governments that are doing voting on chain from many different L2s, you should be able to trust that you can't remove packets of data across chain. So we launched V1 24 months ago, and we're incredibly proud of the fact that we achieved 90% market share. There's product market fit around our Omnichain fungible token standard, more than 600 applications that integrated it. But there were some really key pieces of feedback, particularly ones that for me caused us to go back to those original design principles. The first one there is, in V1, we used this model for off-chain entities that validated messages that used oracles and relayers. And the concept was that any entity that could retrieve and submit a block hash, that could be an oracle. Any entity that could retrieve and submit a transaction proof, that could be a relayer. Now, in practice, the relayer was handling both validation and execution. The challenge of that meant to build a relayer, you had to have wallets on all the chains you were supporting. We were paying for 80 million RPC calls a month, so we were always in the DMs of Infura and Alchemy and at their whims for downtime, uptime. It meant that we had to balance the gas tokens on all of these different chains. When we spoke to other teams asking them if they would build their own relayer, they tried. Even teams like Gelato, some of the best in the relayer space, and it was very complex. So when you have this hypothesis that teams are actually going to build their own components to decentralize themselves, to own their security, what we found was nearly every single team settled for what we called defaults. Defaults were these test settings, and it used one oracle and one relayer. And the relayer it used was the Layer 0 Labs relayer. If the relayer ever had any downtime and you were on defaults, that meant your messages would halt. There wouldn't be any vulnerability, but it meant that there was a liveness issue. And on the Oracle side, even though there were client-diverse oracles, Polyhedra launched a ZK Lite client, Google Cloud launched their own custom oracle, Chainlink spent a year and several $1 million building one for Layer 0 as part of their business. In practice, it was very difficult to build one yourself. So once again, on a spectrum of centralized and decentralized, if you settle for defaults because it's easy, engineers don't have too much time, you're choosing a far more centralized option. And in my mind, the product decisions you make, which are things like defaults, the settings you choose there, that's how you articulate your view of the world. Your designing technology and product decisions are how you articulate your philosophy and how you want people to use your product. And for me, when I think about who we should be building for, it's this person. I dropped out of school when I was 16. I had very little money, only a laptop, short attention span, and was at hackathons trying to make money. And with V1, it was impossible for a student to do that. If you have $100 or very little, you're not going to build a highly performant relayer that can handle execution and validation. And so in V1, though the protocol did achieve those three principles of immutability, permissionlessness, and censorship resistance, it was so prohibitive that in practice, it actually hadn't. And we spent the last year building V2 to solve these issues. So now Layer 0 V2. It's live on mainnet. It has been since January. Testnet was in December. And what's new about V2? It still achieves these three design principles. I think it actually pronounces them even more. Most importantly, it decouples the execution and verification that had been bestowed to the relayer component, and it now makes the modularity and the future-proofing of the security layer easy enough for that college dropout to run it themselves. Unified semantics are still there. So if you're building across Monad and Berachain and also 3 different OP stack chains, all of this, you're using the same syntax, the same approach, rather than trying to, like, in a janky way, put together multiple bridges. And it's a mesh network of 50 plus EVMs and non-EVMs, many, many more to come. Here you can see a walkthrough of a message that comes from the source chain to destination. The sender OAP box, you can imagine as a smart contract I'm using for, say, an Irene token, and I'll walk through that in a second. In that contract is where you have the LZ send function. Then you'll see this purple box where it says LZ endpoint. A key component to our architecture is that the protocol utilizes append-only opt-in libraries for endpoints. So endpoint v1 still exists. It's secured $50 billion of value. It's non-upgradable, so we can't make changes to it. If you've pointed your contracts towards those, you can still do that in perpetuity without anticipating some sort of change to it. But now we've added endpoint v2 to the library, so you can point your contracts towards those. It's backwards compatible. We've also introduced something called lazy non-sorter enforcement. So you can see it where it says lossless channel. In V1, everything was sequentially non-sorter enforced. That meant every single message had to be delivered in the exact order in which it was submitted. That was important to achieve censorship resistance. But the feedback we heard from developers was that for 99% of use cases, that's actually not practical. Now with lazy non-sorter enforcement, messages have to be validated in the order in which they're delivered, but they can be executed or consumed in any order. And then in that central area, in between the passage from source to destination, is a major change. And we'll zoom into this. We call it the security stack. Rather than the oracles and relayers from V1, we've now separated what the relayer had done before. The executor box here, it plays a commoditized role. It's just moving the message once it's been properly verified. So that comes after the DVN component. DVN stands for Decentralized Verifier Network, and I'll walk through what can be a DVN. But the key thing here is, as a developer, when you are deploying your contracts that have integrated the Layer 0 protocol, you select your own consortium of DVNs in an X out of Y out of N arrangement. So that means, let's say today I'm launching, let's see if I can go back in a second, but I'll walk through this so you can see. Today I'm launching the Irene token, and I want it to be omni-chain. I want it to be on Berachain and Monad on day 1. Maybe 2 weeks from now, I want it to be on Base and a few other chains. Very few people are holding my token. It's not that much value. So I select for my DVNs the Nethermind DVN. It's one that uses geographically diverse validators. This is a team I really respect, and they're very Ethereum aligned. And then I also choose the Gitcoin DVN. And these are both live. Gitcoin is running one. I intend to participate in public goods funding. So this is aligned for my community. I say that 2 out of 2 of these DVNs have to agree on the validity of this message. And one of those DVNs that is absolutely required is the Nethermind DVN. For the executor, I choose to use the Layer 0 executor. And as I said before, it's a commoditized role. So Layer 0 is competing in the fair market with other executors. And it's permissionless, so I can swap it in and out. Now it's 2026, and there are 1 billion people who hold Irene tokens. We have a DAO competing with Irene DAO, and we are using an open source executor. I charge 5 bips on top of that. But because I'm securing so much more value, our protocol has grown. It's now time to add another DVN, which is one composed of all of the top Irene holders. And now it's a 2 out of 3 consortium, and I require that Gitcoin and Irene's DVN must secure and validate the message for it to pass. This is showing an example. Hold on, I'm trying to go backwards now. This is showing an example of the modularity of the security configuration. Without writing any new code, you can change that setup. And DVNs can be native bridges. They can be other bridges. They can be a ZK Oracle. This is how Layer 0 actually future-proofs the interoperability layer of your protocol. And what I've written there just shows how X out of Y out of N works. For the executor component, once the verification has passed, then I can choose an executor In this case, Layer Zero Labs runs one. I can run one myself, and that's where I can charge fees. Or I can always link my users to permissionlessly execute, so they just have to pay for their own gas and move their message. Why would you want to use an executor? Because it's a commoditized role, that's where you can add some features. For Layer Zero Labs, we compete by handling something called gas abstraction. If it requires for a message to pass 2 different gas tokens from Ethereum to Solana, rather than needing both ETH and SOL in my wallet, 1 click, only ETH, and the executor does the quoting and exchange up front. And I pay a small fee for that service. But again, I can always opt out or run my own or permissionlessly execute. What can be a decentralized verifier network? These are baseball card visualizations of some that are live on mainnet right now. Polyhedra runs a ZK Lite client. Nethermind, I said, runs one. Animoca and Blockdaemon together have. These are all the different diverse approaches to validation. And we're not opinionated at Layer Zero on what you choose for the validation methodology for your messages. In fact, we very much believe that that should be in the hands of developers. We are competing at the transport layer rather than the validation layer. You can even see Axelar and Chainlink here, their CCIP messaging service. If you believe in the middle chain approach, you can have that as a DVN. But then say your DAO votes to add a ZK Lite client that was built with Succinct's SP1. Great, you can now push that, there's no new code, it's reconfigured. What can they be? They can be, like I said, native bridges, a ZK Oracle, something new, something you've built yourself, always, without having to coordinate with Layer Zero Labs. So back to this person. When I was PMing the launch of DVNs, I was still thinking very much about my college dropout self, and I wanted to be able to run a DVN in under 1 hour myself, something that involves, say, a signer from Stanford Crypto, Harvard Blockchain, Berkeley's group as well. We've now managed to achieve, through a module we created, setting up that DVN in under 1 hour. This is the example I gave. Here are 2 projects that are already live on Layer Zero V2 and are doing things that are a bit more novel than just an omnichain token. Clusters was built by Fubar, who's a security, crypto, Twitter content creator and also just incredible developer I have a lot of respect for. He's created a cross-chain name service. So now Irene / is one name for 7 wallets across different chains. He's built that with Layer Zero V2. Decent is a cross-chain swaps module and protocol. They handle full liquidity cycles for users, so you can on-ramp and off-ramp. That uses Layer Zero and Stargate. They also made a great video that gave me chills, kind of reminiscent of urine-type videos about the state of crypto today. ERC 6551 at MPC Day 2 days ago with the Future Primitive team, we announced that now they are natively cross-chain. Every single ERC 6551 token-bound account leverages Layer Zero V2 and can execute ownership of different NFTs across chains. And now restaking tokens, LRTs, are using Layer Zero to be omni-chain, so they're horizontally composable. 1 click, you can burn and mint from, say, base to ZK Sync. You don't have to wait the 7-day bridge back period and then go to another L2. This is my build this wish list. Only a few here, but I really actually want to see 1-click cross-chain borrow lend, multi-chain account abstraction but applied. Right now, wallets are basically just doing like cross-chain swaps as a widget. We can do better. We can do something different and totally remake the wheel. Omnichain LRTs, as a hat tip to EigenLayer, they keep sending us really great projects that are using Layer Zero to go cross-chain. I was a gamer growing up. I played a lot of Neopets. I want to see a game that is on multiple chains and has, say, like an action on chain A triggers a mutation to an asset I have on chain B. Now it has a crown and it's my Twitter PFP and it's updated. I want to see that, and I want to see it in a low latency format. And then chains treated more as programming languages rather than as commercial real estate. We sort of look at chains like they're our landlords and we're paying some tax to be there, when different chains are actually, inherently trade-offs. And with something like Layer Zero, you can now design it so almost like you have a toolkit of these different languages. I want to do settlement on a ZK L2. I want to have my DAO accrue votes on my own app chain. I want liquidity from Ethereum. You can do all of this. These are the hacks I mentioned before. You have to think about owning your own security. These all came from instances in which too many developers and too many users put their trust into a service, into something that was upgradable and could change on them. Based off of the research I'd done before, you can probably assume that I care quite a bit about people leveraging real privacy tooling and doing things that are both good and bad. The internet is neutral. You can create phishing websites. You can also create really great things. And at Layer Zero Labs, we believe in that too. We shouldn't be able to censor what you do, and you should be able to run your security as you wish. if it can be corrupted, it will be. And so you should choose immutability. And Layer 0 v2 is our articulation of that. That's it for today. Thank you.